Right, so we are carrying on the examples. Let's focus. So, first, this question here. Solve 6, take away 3x equals 12. Now, I've said here, be careful when the variable, what do I mean by variable? What's the variable? Which one's the variable, Jane?
Minus sign?
Not the minus
No, the
sign.
number?
Not the number.
No, the X.
The X. Okay, so the variable is the letter. Okay, so if you remember when we first looked at algebra, we talked about all the terminology. So the variable means the letter that they've used. Okay, so that's the thing that changes, varies. So the variable is the X. So now I've said here, you need to be careful when the variable has a negative number in front of it. Now hopefully you can all see here that this letter X has a negative 3 there, yes? Remember that the negative sign belongs to the thing after it. So my suggestion here is that if you remember when we had these ones, we went through our, we undid their maths in reverse, didn't we? Yes? So we had a look at this and we said, right, let's take away 5. So in order to get rid of that take away 5, what did we have to do?
Didn't we have to do the 13 plus 5? And
Yes.
you had to do 3p.
Good. Remember we had to add 5 to both sides. And so we had 3p is equal to 18. And then we had to say, right, 3 lots of p is equal to 18. How do we find the missing letter? We say, how do we undo this 3 multiplied by p? Someone different today. We've already done this one. Okay, so I've gone back to this example here. Let me just make sure, go back up to here then. So we've got 3p plus 18. So Georgie, what do we do now?
So 3 times 6 is 18, so 3 is 18.
Okay, I'd like to try and, rather than just guess a number, which you obviously know the answer to, what method Rich should do? Good go. You divide both sides by 3. Do you remember that? Because this is being multiplied, we do the opposite operation. So we would divide both sides by 3. And that means that when we've got the same top and bottom, that 3 disappears. Okay, so we're just left with the p on the left. And then 18 divided by 3 is 6. So that's our answer. So Georgie, you knew the answer, but this is setting it out. Now, if you remember, I said it's really, 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 really important that you set these out as I have been. I don't want you to be just going off on your own tangent. Please set them out the way I have been and keep it in a nice orderly fashion so that when it comes to more complicated ones it's going to be a lot easier. Maya?
What does E stand for?
Exponent. Yeah, which letter you used? I?
A? Well, wait. Like any letter? Or?
Okay, in dead maths.
Yeah.
What letter do you know?
Oh, I.
That's why I said there's an I.
I thought you said. Okay.
So it's I or E.
Okay.
An exponent or an index. Same thing. Okay, those have different names. Stace?
You tell us early on that if you set it out wrong, you have to redo it.
Yep.
Until we get it right.
Yep. Did you hear that, ladies? What did Jane say? See, because you were talking. Did you hear it? What did I say, Jane?
That if we set it out wrong, just gonna make us redo it until we set it out right.
Okay, so even if you've got the right answers, it's really important that the setting out is done properly. So you need to make sure that you're doing it in this way. Okay? Right, so do we need to recap this one just in case? Yeah. Alright, so remember this dividing sign here goes all the way underneath this. So what it's like is secretly having a bracket around what's on the top. Okay? So what's our first thing that we have to do to this? Sarah?
We're going to do the step. Oh wait, no, that's last because we're going backwards.
Good, go.
We're going to do we're going to see if there's any subtraction in the oh wait, no, the rest of the bracket.
Yep, so with that,
So you skip that, and you see there's an adding, no. Any multiplying? No. Any dividing? Yes.
okay, so we're going to deal with the dividing first. Yes, you're happy with that? Again, it's working with your eye. Bit math in the opposite direction. Okay? And as Sarah said, even though there is some subtraction, because it's in a bracket, we deal with that last. Okay? So what's the opposite thing to dividing? Remember, we always do the opposite operation in order to get rid of something. Multiply, so we're going to multiply both sides by 3. So we're going to have 3 equals 4 multiplied by 3. Now by multiplying it means that these cancel each other out, so that's no longer there. So we've got P take away 5 is equal to 12. Okay, now I no longer need my bracket here, even though it didn't have one to start with. I don't need it because I was able to cross out my number.
But if you have subtracted some, it's a few more plus.
Sorry, sweetheart?
Like, instead of doing the multiplication sign, you do the subtraction.
So I multiply by 3.
Yeah. No, like, if I have an answer, like,
Oh, so here, this is, well, this was on the top. I haven't done anything with that yet.
she's talking about P subtract 5.
Yeah, I know, that's why I'm pointing at this here. So this is still here. We haven't dealt with that yet, because that was on the top. Yeah? We dealt with the divide by 3 first of all, because that was our weakest spot. Yeah? And so if I've got P take away 5 equals 12, I remember I have to do the opposite thing. So Madison, what am I going to do with this? Good, we're going to add what? 15? Oh, just 5. Good. Good girl. And then that leaves me with P is equal to 17. Good, because these bits cancel each other out. If you needed to do any division, then you would do division. But in this case, we don't, because it's just... It's floating back to us now? Some yes, some no.
This is my least favorite topic. I'm glad we're going back to algebra. That's my favorite.
Okay, well, alright, I don't mind doing this one again. Solving equations is really, really important, even though we have done this. I'm only going to use one method though for this one. Okay? When we went through, if you look at the video, there's 2 different options. Often when we see a bracket, we don't like brackets. So how can we remove the brackets? What process is it called? Do you remember, Abby?
Cancel it out? Or?
Not cancel it out. How can we get rid of a bracket? Because for the...
Oh, I remember this when I said enterprise.
Yes.
Exponential. Exponent.
No.
Expose.
We expand the bracket. Okay, so we're going to expand the bracket. Okay, so expand the bracket. Yes.
Yes.
Not an X, it's EX. No, but that's she. So if we expand the brackets, it means that everything inside the bracket is being what? Multiplied by 3. Good. So instead of 2x plus 1, we're going to have 6x plus 3. Okay, so that says 6x plus 3. I'm sorry, the board's playing up as usual. Equals 21. So then we go back to our normal method and we say, right, what's the weakest bond? Have I got any addition and subtraction?
No.
Yeah?
Wait, 6x plus 1
3, sweetheart, 3.
equals 21.
Yeah, equals 21 in the first.
Oh, yeah.
That hasn't changed.
Okay.
So we need to get rid of this plus 3. So we always do the opposite. So what's the opposite of adding 3, Kasika? Good girl, so we're going to do that to both sides. Okay, so this has disappeared. So we've got 6x is equal to, what's 21 take away 3? Jane?
18.
18. Okay, so if 6x is equal to 18, Kaya, what am I going to do next? Do I need to get x on its own? So if I've got 6 lots of something, what's happening to the 6 and the x? So they're being added, subtracted, multiplied, divided. They're being multiplied at the moment, so to get rid of it, we have to do the opposite. We have to divide. So we're going to divide both sides by whatever number it was there. Okay, so had it been 74, we divide by 74. But we're going to divide by 6, because that means that we can do that. Okay? And that gives us x, and then 18 divided by 6 is 3. Okay, this example here, I'm trying to make it clear that it didn't matter which side that the letter was on. So whether the letter is on the right or the left, it doesn't matter. Now, if it freaks you out, as I said before, if it freaks you out that it's sitting over here, if you don't like it over here, just rewrite your question. So if you would prefer, you can start off like that. Okay? If that makes you more comfortable. So if you are more comfortable doing that, that's fine. So please do not change any of the signs. Okay? You just rewrite it on the left-hand side if that's where you want it. So, what do we need to get rid of first of all on this left-hand side? Maya? The divide by 2. And how do we do that, Maya? What's the opposite of dividing by 2? So we're going to multiply both sides by 2. Okay? Now, that means that these 2's cancel each other out on the left-hand side. So we just have p take away 3 equals 24. Now, for this example, I didn't write it in, but what could I have written in to help us a little bit? The fact that this dividing went under the whole thing, it implies that what was secretly here? Secret brackets. Okay? You don't have to write them in if that makes you uncomfortable, but just be aware that they are there to keep them together. And then, so what's the opposite? What we're going to do now to get p on its own? So we've got p take away 3 is equal to 24. How am I going to find out what p is? If you take away 3, sweetheart, this isn't going to disappear. We need to try and make it disappear. Pardon? Here we go. You add 3. We'll do the opposite. All right, so we're going to add 3 to both sides. So what happens is, if you look at this here, if you have the take away 3 and the plus 3, that merges and it disappears. Yeah? So then p is equal to, and what is 24 plus 3? 27. Okay? Right, so that's a good recap of that page. There were some other examples that we started off with. Right, so now moving on to new examples. Now, the reason I've done this one here is because sometimes your variable will have this negative sign in front of it. Now, do you remember here I said to you, right, if it freaks you out, just rewrite it, but don't change any signs. Okay? Now, what I'm going to suggest here is that if you've got to take away 3x, I would suggest that you add 3x to both sides. Now, what that does is it makes my value of x positive. So I've got 6 is equal to 12 plus 3x. Now you may be sitting there saying, well, what on earth has she done that for? It hasn't made anything any simpler. I've still got the same number of things there. Okay? Now the reason is because if I left it like this, sometimes people make mistakes with the fact that it's negative. So I would rather always make sure that you have a positive value there. Okay? And then we say to ourselves, right, okay, we've got 12 plus 3x over here. I need to get rid of things. So what's the first thing I'm going to get rid of on that side, Georgie? On this side, what's the first thing I'm going to get rid of? Remember, dead math backwards. Good girl, the plus 12. So we're going to get rid of this here. So we're going to take away 12 from both sides. This. Alright, so we're taking away 12 from both sides. That means this has disappeared. And what's 6 take away 12?
Minus 6.
Good, negative 6. Abby, what's the next thing I have to do to get x on its own? Okay, so we look at the x because that's what we want to have on its own. What's happening at the moment with this x and this 3? Are they being divided? They're being multiplied. So what did we say we have to do to undo something? We have to do the opposite, which is divide. So we would divide by 3.
Why by 3?
Because that's the number that we had. If had this number been a 15, you would divide by 15. If this had been a 6, you would divide by 6. Because what's happening is that we want to divide by 3 because we know that the rules of fractions is that if it's got the same top and bottom, it means we can get rid of it. But only if it's the same. Okay? So that means that x is there and negative 6 divided by 3 is negative 2. So x is negative 2. So that was the one that could have taken some of you out your comfort zone because we had the x on the right hand side.
Well, I didn't realize.
But that's the thing, it makes no difference in doing the same thing, yeah? Alright, next one. Oh. Alright, so the next one. So again, we're looking to see what's the first thing we need to deal with. What's our weakest bond? Looking at dead math backwards.
Brackets.
So are there any brackets here?
No.
No. Remember we're doing dead math backwards. So addition and subtraction has equal importance, division and multiplication have equal importance. So is there any addition and subtraction going on?
Yes.
Yes, and it's separate from this fraction, isn't it?
Yeah.
And so that means that this bond is the weakest bond and that's the thing that we need to undo first.
Well, there's a tiny bit more.
Do you mean like that?
Yeah, that's the thing.
So you're not copying it yet? So Jade's asking, what do I mean by this strongest bond, weakest bond thing? Georgie, can you pay attention rather than erase thank you. So if I were said to you, right, we need to follow this rule. Ignore the fact that it's equal to 7. Okay? If I said to you we're going to deal with this rule, and I'm going to get Maya to pick a value for x. Okay? So Maya, ignore the 7 for now. What value would you pick like? Any number. Today would be good.
5.
5. Okay, so Maya's chosen 5. So how would we work out the value of this expression here? What would we do with the number? We would do what to it? Well, tell me the order. What would we do? We would multiply it by 2.
Then you get
Yes.
10.
And then we would, we'll be careful.
Divided by 10?
No.
Divided by 5.
So we're going to just use this rule. So if I were to have a value for x, which Maya's chosen to be 5, I would multiply it by 2. Then what would I have to do with it? I would have to divide that by 5. Yes.
2.
And then I would take away 3.
Minus 1.
So that would be our answer. Now, what I want you to think about is the order that we did that. We did the multiplying, then the dividing, then the subtraction. So when I said about the weakest bond, I mean what thing did we do last in that process? So that was that take away 3. So that's the thing that we're going to get rid of first. Does that make sense?
Yes.
Whereas for, particularly for things like this, if you were given a value here, we would take 5 from it, and then we would divide by 3, and then we would get an answer. So it's all to do with what what's the last thing that you would do in your process? Okay? Right. Oh, Lord above. So, what did we say is the first thing that we're going to undo, Georgie? The takeaway 3. And how do we undo a takeaway 3, Sika? Good go, you add 3. So we're going to write add 3, add 3. So on the left-hand side, what will have disappeared? This stuff here will have disappeared, won't it? Yes?
Mm-hmm.
You're happy with that? So that's gone. So I've got 2x over 5 still, because I can't do anything with that, is equal to, Kaya, what am I going to write now?
Well, 6. No, 7.
10.
10? We get 10. Oh, 10.
You see that?
I see the 7, I see the 3.
You see the plus?
So, do you see how on this side we added 3 and that disappeared, so that we didn't have to write it anymore?
I see!
Yeah?
I was looking at the one.
Okay? So here we're going to add 3 as well, so you must make sure you always do the same thing.
Okay.
Okay, so this one is a 3.
Is there a 6? Yes. Does it matter which number you get?
Okay, for solving equations, we are trying to find the one value that makes that true. There is only one answer.
So it
Okay.
does matter what x becomes?
Yes, very much so. Now, if you
Because
recall,
Maya chose 5, but
oh yes, no, but do you remember I said to ignore, that's when we were ignoring the fact that it was equal to 7. So if I gave you this, I could say substitute the value of x for anything you wanted. And that's substitution. So that's what we were doing last time. So you would substitute it in and you would get a value. You would tell me what it was equal to. Okay? Now what we're saying is that that expression is actually equal to 7. It has to equal 7. We need to find out which number do we have to stick into here, which number do we have to replace that with, or which number do we substitute in order to get the answer of 7.
find which numbers.
And that's what we're doing, we're solving it. So what we're doing is we're working backwards. So rather than start with a value and multiply it, then divide it, then take away 3, we're starting with our answer and working backwards. Okay, so we're undoing everything here.
Maya just happened to pick the right number.
No, Maya didn't pick the right number. Because when we chose Maya's 5, we got 1 or something.
No, we got -1.
Negative 1.
No,
No, you didn't.
we got -1 and we chose how.
I don't remember what we got.
We got -5. So we did.
Yes, we got -1, so it wasn't 7, it was -1. Okay?
It was just pretend.
We're trying to find a number to do. No, but we did 5, we did times 5, 10,
Divided by 5.
5,
No, 10 divided by 5 is 5.
2.
2. What's 2 take away 3? It's -1. Okay, so that wasn't the correct answer. Alright? So we need to find out what the correct answer is. So now we're going back to the left-hand side. So we've got 2x over 5. What's the first thing, Jessica, that we need to undo here? Do we need to deal with our multiplying or our dividing first? Are you just picking one randomly, or are you looking at the question? Be honest. You're just picking one randomly. Okay, so we have to look at this. So let me help you decide. So this underline goes underneath both the 2 and the x. Okay? So we want to try and get rid of the weakest thing. So the best thing to get rid of here is the 5, first of all. Okay? Because that's underneath, that's being divided. So how do we get rid of, or undo, or divide by 5? What did we say the opposite process? We multiply by 5, good. And so we have to do that to the set both sides. Yes? So we're multiplying both sides by 5. So that means that on this left-hand side, we can cross that out. That's made our life a lot easier. That's gone. And so we've got now 2x left here. And then 10 multiplied by 5 is 50. Awesome. So we're only left with one process now. We've got 2 and x. So what's happening to these, Kaya? So what's the opposite? Exactly right. Exactly. She sped up there at the end. So x is equal to 25. Right. Okay. Next question. What do we have here that we dealt with some of those previous examples? What do we have here that we think we're going to have to do something with?
The 4 and the brackets right next to it.
Good. And how do we get rid of it? You should all be able to spell your words. You expand them. Good. Now, here's a question for you there. You've got to be really careful. This 4 is only, it's not really a question, it's only attached to this bracket. Okay? This 4 is nothing to do with this. So you've got to be really careful here. Sometimes people see numbers in front of a bracket and they get all excited and start multiplying everything by 4. But the 4 is only affecting the bracket. Okay? So Sarah, how am I going to expand my bracket? Instead of 4 lots of x minus 1, what am I going to write?
You're going to write 4 and then minus 2x.
No, sweetheart. We need to expand our bracket.
X will equal 1.
No, because we've got, remember, everything inside our bracket needs to be multiplied by 4. So when we've got 4 and we're multiplied by x, what do we get?
4x, and then you get 1 more, take away 1, and that's 3, so you make
No, so remember, it's not just 4 take away 1. What's happening to these things? They're being multiplied. What's 4 multiplied by -1? Pardon? Good girl. So we're going to write 4x minus 4. So that's my expansion done. Okay? I've still got take away 2x equals 2. I've written it flat to try and help separate the colours, to separate the process. So the red is just my expanding. Okay? My take away 2x is still there, and so is my equals to 2. Now, the rules of any kind of algebra is that if I have things that are, remember, called like terms, I have to join them together before I deal with them. So, is there anything on this left-hand side that is a like term? Jace?
4x minus 1.
Good girl, and you said it very well. 4x and minus 2x. So we're going to join those together. What's 4x? Take away 2x. 2x. Good girl, children. So we've got 2x, take away 4 is equal to 2. So my green process was just joining like terms.
Good.
Okay, so my green process is joining like terms. So I'm trying to help colour code. So the red from the first step was expanding that bracket.
Where's the 1 go?
Because remember, we had to multiply everything inside the bracket by this 4. So we had 4x, and 4 multiplied by -1 gave us -4.
Since I both x and they're similar, doesn't that mean that we can do 4x equals 2x?
That's what we did here, sweetheart.
Oh, I thought everything something else to do with it and everything.
No, we joined in like terms. That's why it's in green. So I circled it in green and then wrote the answer.
So what happened to the x, 5, and 4?
Because we had 4 x's and we took away 2 x's, which gave us 2x.
Oh, Oh, and then-
Remember, like 4 pigeons, take away 2 pigeons, gives us 2
And
pigeons.
then, oh, I think that I thought that was supposed to work.
Okay? Right, so N squared thinks she knows what to do next.
Says that I have a question. Why did you put the 2x first at the bottom?
No particular reason. So I guess because I dealt with that first, in my head I read 4x equal 2x. You could have written minus 4 plus 2x if you prefer.
Why would you put minus?
Because this, remember, the sign belongs to the thing after it. So that's super important. So if you were going to deal with writing them in a different order, you must make sure that the sign is with it, the correct sign. So this takeaway sign has to stay with the 4.
Then what's the takeaway so with the 2x?
Because we did 4x take away 2x. Okay, we'll do some practice of this and hopefully you can get a little bit of practice.
I have
Alright, so n squared, what do you think we have to do now?
So instead of
It's
this
more.
minus 4, you have to do plus 4.
Good girl.
That ends the 2.
Good, and that means that's disappeared.
Yeah, and then we do the 2x equals 6. And then we divide it both by 2. And you'd be left with the x equals
Good girl, awesome.
10. Or
Good. Okay, I'm going to leave you to have a look at that.